Well, good afternoon, everyone. It's John with Empire Weather. Hope you're doing well. Today is Sunday, March 10th, and we are reviewing the latest on North American agriculture. And we're going to start by looking at where we were this winter. We know it was one of the warmest winters ever. I don't feel like we really need to get into that too much. Everyone knows it's been all over the media. It was a very warm winter, especially in the northern plains, Great Lakes, and the Northeast. But what did precipitation look like? And you'll notice immediately that I'm using a period from January 1st or December 31st through March 10th. And the reason for that is because there was some early season rain and snow up in the northern plains that really skewed this back in very early December. And when we look at the winter, typically we look December to March, but I feel like that is so long ago now that this gives a more accurate picture of what we've really been dealing with since January 1st. If you think of all of January, all of February, and now the first couple weeks of March, here's where we've been. So a couple things stick out. Immediately, we see the northern plains and the upper Midwest have been well drier than normal. That is well documented, and that area has really missed out on several significant systems. The storm track has largely been through the Rockies and the plains and then redeveloping off the East Coast. So the Northeast states, essentially from DC through New York and up to Boston, has seen one of their wettest winters ever. And it hasn't all been snow, especially near the coast. It hasn't really been snowy at all. It's just been extremely active in that region. And that storm track and that moisture has come through the plain states. So we've seen an active winter from Colorado and southeastern Wyoming into the central plains, and then into the Ohio Valley has been decently active as well. But this dryness up here is really important. Northeast Wyoming and southeast Montana into the Dakotas, Minnesota, Wisconsin, and even parts of Iowa. And the reason that's important is because this area wasn't overly wet last year either. I'm sure you remember we had those late season storms as we went through the summer in 2023. But this area up here in particular, they didn't get all of those storms. So now we're in our second period of prolonged dryness in this area. And I think that's something that we're going to need to watch as we go through this spring. Let's look at what actual soil moisture is telling us and what has been happening over the last several days. So this is the precipitation over the last 60 days. And this agrees with what we were just looking at, right? Look at the activity here in the eastern United States, just storm after storm. We also have that storm track coming through the Rockies and into the central plains, and we can see very clearly some dryness down here in the southern plains and some dryness right through that corridor of the northern plains where we saw the climate districts reporting the dryness there. So that leaves us with this anomaly over the last 60 days, and this makes some sense, right? We see the dryness up north, their active weather in the plains, and then the dryness a little bit in the southern plains, and then this very broadly wet pattern east of that. So it a little bit of a mixed bag here. I think if you look back, though, in general over the last 90 days, I want to just focus on this region. This area of the plains has really benefited from precipitation if we go back 3 months. I don't necessarily think that it's worth paying too much close attention up here. Right here in the central plains, this is going to end up being critical precipitation when we head into the spring. And I'm going to break down why, because it's going to help us understand how these individual storms are going to develop moving forward. So here's what the latest root zone soil moisture map shows. This is NASA GRACE-based root zone soil. And we continue to see this area of dryness in the Midwest and Ohio Valley. Again, this dates back to issues from last summer and the fall. This data appears, and this is just based on a lot of conversations we've had on the ground with folks. It's definitely dry in this region. It's definitely not a 2% or 5% wetness percentile that these maps are indicating. This can happen sometimes with this satellite-derived data. What I'd like to look at, though, and just look in general, is that this area has been a little bit drier. It was near average for the winter. A lot of the wetness was here in the east and then here through the central plains, not necessarily in this region. So Iowa into Illinois, Indiana, and especially we mentioned this area of the northern plains here. We want to keep an eye on this moving forward. So there's a couple areas we need to watch as we head into the spring. What does a short-term forecast hold? Let's check it out. Let's check out the European model. I'm going to back this forecast up because early in the week, there isn't a ton going on. We have a storm system that really wraps up in the eastern United States. This is Monday morning, so we have a very windy start across the eastern United States on Monday morning. And It'll keep temperatures relatively normal, a little cool in parts of the Ohio Valley. But as we go into the middle of the week, look at how quickly this warmth expands. Monday and then Tuesday across the north central plains, we are well above normal, much warmer than normal. And then Tuesday, the central and eastern United States are just cooking compared to normal here. The actual temperatures during the afternoon, if we zoom in to the central United States, this is Tuesday afternoon around 3 o'clock p.m. We are well into the 60s across the Ohio Valley, the Midwest, and then if you're in the central or southern plains, you're talking 70s, 80s in some areas. Then we roll this forward into Wednesday. You see you cool down overnight, obviously. And on Wednesday, we warm up again, but you're starting to see the development of a front here coming out of the plains and into the Midwest. And so that's going to be our next storm system that we're going to need to watch here across the central United States. Here comes the storm on the models. This low pressure system ejects out on Wednesday afternoon and evening. So you get precipitation developing across the plains. I'd watch the potential for some thunderstorms in Kansas, Oklahoma, and down towards the Red River here in Texas on Wednesday afternoon and evening. The models show very consistently, and they've done this for a couple days, an axis of instability here. And when we look at the wind speeds aloft on the models, there's a jet stream coming right through the southern plains here. Anytime you have a jet stream and moisture and instability, you have to watch for thunderstorms. So while the models might not be showing anything, Kansas, Oklahoma, down this dry line into Texas, I think we watch on Wednesday afternoon and evening for thunderstorms. But other than that, we have snow in the Rockies. We have precipitation developing here throughout the plain states. It looks like a sort of consistent rain Wednesday into Thursday for Nebraska, and then into Iowa. They really need the precipitation. We just talked about that, right? So we see this rain through Wednesday and Thursday, and then the system shoots off to the east Thursday night into Friday. So here's what we look at, just overall precipitation totals through the week. Here are your scattered showers and storms, Oklahoma down into Texas, and then your rain and snow in the Rockies, and then this band of precipitation which comes through Nebraska into Iowa and then Illinois, Indiana. So good moisture here. Our friends in the northern plains, they're missing out again. This is another system that does not get up there. So the Dakotas, Minnesota, Wisconsin, they're not seeing much from this storm again, and we're going to have to keep a close eye on that moving forward. So this system moves through, and that takes us into the period around March 15th. So what do the models do? This storm goes off to the east, and you can see it kind of just de-amplifies. It doesn't really turn into a huge storm. You get some rain in the eastern United States, some rain shifting off into the southeast Thursday into Friday, and then this deep low pressure comes down from Canada and really ramps up the cold air. So if we want to go look at, what the possibilities are with this system, and we pull up the wind speeds, this is a big northerly wind front coming down next weekend. And that signals that this warmth might not actually be here to stay. We might be dealing with a cold shot coming up, right? Is there reason to believe that, or is this just model fodder? It is not. There's reason to believe it, and we've been talking about it for a couple weeks in our products, just that we've been expecting a cold shot during the second half of March. One of the major reasons for that is this. This is the stratospheric polar vortex strength. And listen, there's a lot of fancy terms and mumbo jumbo that's out there when it comes to the stratospheric polar vortex. All you need to know from an operational perspective is the stratospheric polar vortex always exists, and it exists in the stratosphere, which is tens of thousands of feet above our head. However, it has a relationship with what happens in the troposphere. That's where we are. That's where our weather is. And so when the stratospheric polar vortex, which is way above, when that breaks down and weakens to this level, a sudden stratospheric warming, it can affect the tropospheric polar vortex. And it can lead to the development of ridges of high pressure way up in the Arctic that move that Arctic air around towards our area. And so that's what we're starting to see on the models as we move into mid and late March, right? That we know the vortex is weak in the stratosphere. And now we see the models bringing blocking up here, up into the west coast and up into Greenland as we move into mid and late March. You see all these oranges and yellows here. That's higher than normal heights. That's ridges of high pressure. And so what that is going to do is it's going to take air that typically resides here and dislodge it down into the United States. And so here's the end result of that. What the models show is this big warm pattern we've been stuck in almost completely reverses because of that blocking. And we get into a colder than normal pattern. This is the week of March 18th, so this is actually the 19th to the 26th. But we see a colder than normal pattern developing through late March and probably lingering at least a bit into the first week of April. as that blocking just continues to exist up there in Greenland, in Canada, in the Arctic. When you have these ridges of high pressure here, they take the air that's usually here, they drop it into the United States or towards Europe. And so that's what we're seeing here with this pattern. And we're confident that as we head into mid to late March and early April, this pattern is going to get colder again, and it's going to feel like spring is on hold. But it won't be on hold forever. And boy, do we have a lot to discuss as we head into the spring. So let's take a look at the long-range forecast. The first thing I'm going to show you guys is sort of the breaking news of the later part of last week. Colder anomalies appearing here in the equatorial Pacific. This is the beginning of the development of La Niña. You can see it happen right here towards the end of last week, appearing in the equatorial Pacific. So what is La Niña? Why is it important? I mean, the very, very high-level basic stuff here is that La Niña and El Nino, it is just a periodic circulation that has a periodicity to it. It goes back and forth, and it affects the atmospheric circulations that then impact our weather. So when you have an El Nino, you tend to get a more active jet that pushes towards the United States. When you have a La Niña, you have cooler waters here in the Pacific, and it impacts and weakens the jet stream in the North Pacific. That's a very, very high-level way of looking at it. But the point of the matter is that there's more to just, is it El Nino or is it La Niña? There is a certain sauce that exists in the transition period between the two, and that is going to be falling right in the middle of spring and growing season here in the United States. We are going to again be in a transition. Last year, 2023, we were in a transition from La Niña to El Nino during spring. And I'm sure you remember it was very dry to start. And then all of a sudden, once the El Nino circulation kicked in as we went into summer, the moisture came in. This year might be just the opposite, where it's very wet to start, and we flip sometime during the middle of late spring or summer, and the moisture turns off, which creates some concern for us. Anyway, before that, though, here comes the La Niña. We see it developing. If we look at the forecast, this makes a lot of sense. These are the predictions from early February. We will get an update to this chart, I think, next week. But the long and short of it is that we expect La Niña to develop quickly as we move into the spring. However, there are major differences between these models. If you just look at the April, May, June tri-monthly period, this and this are very different. One of them is still a weak El Nino. The other one is a developing La Niña. So we have a big spread in how fast this is going to develop. If we look at what's happening right now, and bear with me, this is a really kind of old school graphic. What we're seeing is the upwelling of colder water. So we're looking at the depth here, looking down. This very top is the surface of the water, what we see when we look at sea surface temperature maps. And down here, this is going deeper and deeper into the ocean. So watch this cold pool. Here's your El Nino in January. Look at the cold pool pushing up. Here it comes, pushing, pushing, pushing. And we know that it has just surfaced as of recently when we look at this chart and we see the La Niña just pushing this way up towards the surface. But what this tells us is that we're going to continue to see the development of La Niña through the next couple of months. And it's probably going to develop fairly quickly. However, what we don't know is how quickly. Does it develop? Are we in La Niña conditions and circulations by late spring, or does it wait until summer? And the two things will be very important and to figure out which one's going to be the more dominant one. Now, with that being said, as we head into spring, we talked about it, we're in a transition, right? We're right in between El Nino and La Niña as we get into spring, April, May, and June. What does that usually mean for us, right? One thing we did when we put out our spring forecast a couple months ago is we put together analog years. And here's a great example of it. This is what we put together for March. These are all the years that were similar to this year and featured what we call a terminating El Nino, so a dying El Nino, and then a La Niña by summer, and also featured similar sea surface temperature orientations. Now, there's a couple things you're going to note. This March analog set is doing pretty dang good so far. We have troughing and active weather coming underneath a block, which develops here over Canada and north of Alaska. We just looked at that blocking that's going to come in late March, and the troughing that's going to come underneath it. So the analogs so far are doing a pretty good job, and we can trust this overall look, right? We're going to have to add and remove some years as we go forward, but right now we're looking pretty good. So that's March. What do these analogs show as we move further into this La Niña pattern in April, May, and June? Well, here's what the composite looks like in April, May, and June. And the first thing that sticks out is this big blue trough across the west coast. I'm going to draw on this map here and show you why this is important. When you have a trough that sits here on the west coast, the flow around it ends up something like this, right? So you have a jet stream that's pushing into the central United States. Here is a weak signal for a high pressure across the eastern United States. And so what happens then is you have a return flow around from the Gulf into the central U.S. And the combination of this trough and this ridge is going to lead to a very active weather pattern across the central U.S. You have your jet stream this way, and you have your moisture this way. And overall, for April, May, and June, this is signaling a very active weather pattern. Now, we looked at other years, and when you look at this pattern, if you are tuned in with storms at all, you'll know that this is also a very stormy pattern. And I said to myself, there's got to be some research out there on this, right, to kind of back this up. So we went and found this, which is a paper from 2016 talking about the tornado outbreaks and their links to ENSO phases. And lo and behold, when you have a early terminating El Nino, there is a heightened chance of outbreaks across the Midwest, the plains, and I mean generally when you look at anywhere from the central plains into the upper Midwest and parts of the Great Lakes. And here's your ENSO evolution in spring from El Nino to La Nina. And that's exactly what we see being forecast here. So with storms, obviously, comes a heightened chance of rain, and we see on our analogs a very active weather pattern. Now, do the weather models agree with that? The answer is a resounding yes. The European seasonal and the latest CFS data all agree that this is going to be an active spring. This is the March, April, May tri-monthly period, and we see active precipitation patterns across the plains into the Midwest. This is your April, May, June pattern, and you see, again, very active weather developing across the plain states. So it's increasingly likely that we're going to be in an active, stormy weather pattern. You can even sort of see where the dry line would set up here throughout the central plains in Oklahoma and Kansas and back into Colorado, and this coming off of this boundary between dry and wet. Right here is where you get your storms to fire, and they push this way, and that's how you get thunderstorm and rain complexes in the plains. So it's looking active through April, May, and June. But if you're like me and you're always looking at the potential risks, your eyes probably went down here. That's into the desert Southwest and Texas. Everyone, all our clients that we know, moaned and groaned when I told them that La Nina was coming back down here in Texas, essentially Lubbock, Amarillo, down further south, Del Rio, or even further west into New Mexico, because La Niñas almost always bring dry transitions there. And so look at what the models are saying. They're saying, yep, here we go, right? March, April, May looks like this. May, April, June looks like this. And then May, June, July looks like this. And what this is expanding drought and heat risks across the Southwest. And the reason why this is important is because the speed at which this La Nina develops is going to be really important. There's an elevated mixed layer here, an area of very warm, dry air that builds in the higher elevations here of Mexico, New Mexico, Texas. And if this La Nina develops faster, what we will see is this elevated mixed layer and this dryness and heat start to expand out into the ag belt. The models are not necessarily showing that just yet, but they are hinting at the possibility. So my concern is elevated specifically for the southern plains as we get into summer. I think there will be some activity early on, but then it looks like this dry line is going to set up somewhere in the central plains, which leaves Texas, the Texas Panhandle, western Oklahoma down into these regions of New Mexico and possibly even southwest Kansas in a little bit of concern, because you don't want all the storms firing off to the east. For a large majority of the ag belt, though, this looks pretty good. We're just going to have to watch the southern plains really closely as we head into the spring and summer. So again, the highlights, right? Let's back it up real quick. We have a colder pattern change coming as we head into late March. Spring is not fully here yet. It's going to be here for the next several days, but we're going to get colder in late March and early April. And then as we head deeper into April, the idea is that it's going to warm up and get active. The models start reducing the blocking, and you can see the active weather pattern, that southwest flow here. So when we head into spring, it looks very active across the central plains, across the Midwest, the Ohio Valley, and we'll probably get quite a bit of shower and storm activity. Should be an active year for thunderstorms, severe thunderstorms in the plains, and then we're going to have to watch this mixed layer of dryness and heat and see if it expands into the Midwest and plains. Could have a huge impact on the growing season as we get into the summer, and it's all going to come down to how fast this La Nina develops. So stick with us. If you guys have questions, leave them right here in the comments or shoot us an email. Thank you so much for watching. Have a great Sunday. We'll be back with a client video very early on Monday morning. Take care, guys.